Oh well, this is B. Chandrasekhar of LE301 and from A section. Today I am going to explain the topic about the deformation of plastic and elastic limits. So first of all we need to know what is the deformation. So here is the definition of the deformation. Deformation is the action or process of deformation or distorting, such as any mechanical objects such as cars, let's take vehicles or anything undergoes some deformation, slow and transform deformation. Oh, sorry for the distance. And then in every engineering applications, the solid structures. Sorry, in every engineering applications, the solid structures are subjected to external loading. Such loading can be broadly classified into two categories: normal load and the shear load, tensile and the compressive load. These different types of the normal loading are all together by loading such as bending, torsional, etc. are basically combination of the basic types of the loading. When sufficient external load is applied on the solid body, it undergoes deformation. The very basic mechanism of deformation is the shifting of the layers of atoms from their original lattice position under the influence of the external force. Whenever the external force acts on a mechanical body, for example, we have for example even near our college, when the students enter the bus automatically goes on the bus frame. You can go the chassis of the bus undergoes some on some deformation and it bends to the one way, so that it is common. The deformation occurs in the many things, and now we basically concentrate on plastic and this elastic deformations. So when such shifting or displacement occurs in a very small length, the atoms can revert back to their corresponding lattice sites. After the external load is removed, such deformation is termed as elastic deformation. Thus, the elastic deformation is temporarily makes no harm to the structures. For example, our rubber band, no matter what we elongate until its break point, not to be mentioned, the point to be noted. Until the breaking point, it doesn't makes any effect. It again get back to its original position, so nothing problem with it. So thus elastic deformation is temporarily and makes no harm to the structures. However, its atoms displaced by long length, then the deformation becomes permanent. For example, you elongate too long, it gets broken, and you know that such deformation is termed as a plastic deformation. Okay, and the entire structure can be changed its original shape and size because of it. Various similarities and differences between the elastic deformation and plastic deformation as presented in the below table form. So here comes the similarities. Now we learn about the similarities between the elastic and the plastic deformations. Any type of loading, not that may be normal load, shear load, or may result both types of deformation. The plastic deformation can occur only after the material is easily deformed. So without elastic deformation, the plastic deformation is not possible. Both elastic and plastic deformation are useful. However, based on the applications, mainly based on the applications, different between elastic and the plastic deformation is given as following. So the elastic deformation is a temporary deformation under the action of external loading, suppose example rubber bands. And the plastic deformation is a permanent deformation. For example, you elongate a carry bags. For example, our plastic carry bags, if we elongate once, it gets permanently it gets deformed. So that's once the external load is removed from the elasticity form, it regains its original position. For example, even our daily use rubber, pencil rubber, eraser, I mean, if you bend it and you release at a point and it get back to its position. But in the case of the plastic deformation, when the body is physically deformed, it retains its deformed shape even after the removal of external load. For example, okay, limit. In elastic deformation, atoms of the material are displaced temporarily from their original lattice site. They return back to their original position after the removal of the external load. In the plastic deformation, the atoms are solid. Okay, is the video running? Okay. Original lattice side, they don't return back to the original position even after the removal of the external load. The elastic deformation is characteristic by the property elasticity. By definition, elasticity is the property of the solid material by virtue of its width it tends to regain its shape after the removal of the external load. The plastic deformation is characterized by the property of the plasticity. By definition, plasticity is the property of the solid material by virtue of which it tends to retain its deformed shape even after the removal of the external load. The amount of elastic deformation is very small. The amount of plastic deformation is quite large. Energy absorbed by the material during the elastic deformation is called the module of the resilience, and the total energy absorbed by the material during the elastic and the plastic deformation region is called the module of the toughness. And Hooke's law of the elasticity is the applicable within its elastic region. Hooke's law is not the applicable if the material is plastically deformed. Most solid materials display a linear stress strain behavior within its elastic region. The stress strain curve is nonlinear in plastic region. Materials first undergo elastic deformation under the application of the external loading. The plastic deformation occurs after it is elastically deformed due to the application of the external load. Mechanical and metallurgical properties of the solid materials remain altered when it's elastically deformed. Many properties of the solid material change considerably of the plastic deformation. And so here is the deformation, yeah. So here this is the deformation of a thin straight rod into a closed loop. The length of the rod remains almost unchanged during the deformation, which indicates that the strain is small. In this particular case of the bending, displacement associated with the rigid translations and the rotations of the material elements in the rod are much greater than the displacement associated with the straining. Deformation is a continuum mechanics is the transformation of a body from the reference configuration to the current configuration. A configuration is a set of containing the positions of all the particles of the body. The deformation may caused by external loads body faces, such as the gravity or electromagnetic forces, or changes in the temperature, moisture content, or the chemical reaction, etc. The strain is a perspective of the deformation in terms of the relative displacement of the particles in the body that executes rigid body motions. Different equivalent choices may be made for the expression of the strain field depending upon the whether it is defined with respect to the initial or the final configuration of the body, and on the whether the metric transfer on its dual is considered. In the continuous body, a deformation field results from a stress in field. So similarities between the elastic and the plastic deformation. Any type of the load, normal or the shear, or may result both types of the deformation. The plastic deformation can occur only after the material is elastically deformed. So without the elastic deformation, plastic deformation is not possible. Both the elastic and the plastic deformation are useful. However, based on the applications, they are helpful in different states. And that's it. Thank you.